Thank you very much for joining in our day's class in the unit of Education Planning 914, Basic Education Statistics. Last time, we were looking at the measurement scales, and this time round, we are introducing another subtopic, and this subtopic is organizing data. Organizing data. It's very important for us to know that when a researcher goes in the field, he collects data, and this data is most likely to be unorganized and somewhat overwhelming. Now, this data that has been collected is not suitable, is unsuitable for interpretation because it's not organized in any way. So the researcher needs now to put this data in order for it to have any meaning. At this stage, this data that is unorganized, we call it raw data. This data must be processed in order for it to have meaning out of it. And the primary stage of processing the data is organizing this data in order for it to have any meaning that can make sense to a researcher. There are several methods of processing data or organizing data to have its meaning. And some of these processes that are given in statistics are there to organize this data so that when we look at the data has a meaning. And in statistics, that organization refers to the process of structuring and arranging data for statistical analysis. So when we are talking about data organization, we are simply referring to the process of restructuring and arranging data for statistical analysis. This involves preparing the data in a format that facilitates the application of statistical techniques to extract meaningful insights and draw conclusions out of the data. Now, what are some of things that are done when we do the data organization? The first one is data cleaning. Before analysis, it is essential to clean the data by identifying and handling missing values, outliers, inconsistencies, and errors. This ensures the accuracy and reliability of the statistical data analysis. The second thing we do is data coding. Categorical variables need to be coded numerically to be processed by statistical algorithms. For example, we assign values to categories such data such as male and female. So you will get us assigning male to take a value equal to 1 and female taking a value equal to 2. That's what we call coding. And there are several other ways in which we can do the coding of the data. Number 3, data transformation. In some cases, the data needs to be transformed to meet the assumption of statistical tests or to improve the distribution properties of the variables. So when we transform the data, we are only trying to help so that this data might meet the assumption of statistical tests. And when we'll be doing these tests, we will see these assumptions that are in each test we use in statistics. Also, another thing we do in organizing data, it is variable selection. Depending on the research question and the statistical analysis objective, variable may need to be selected or excluded from the dataset. This process involves considering factors such as relevance, correlation with other variables, and the potential multicollinearity. We will come to multicollinearity when we'll be dealing with some of the statistical techniques or tests, such as multiple linear regression, because this one affects the data at that particular stage. Also, data structuring is another point we consider when we are doing organizing of the data. Data should be organized in a structured format, such as a table or a spreadsheet, with each column representing a variable and each row representing an observation or a case. This tabular structure allows statistical software to analyze the data effectively. Also, when we are doing data organization, we do what we call data aggregation. Sometimes data needs to be aggregated to a coarser level to analyze the patterns and also to analyze the trends in the data. Aggregation can involve summarizing data at a higher level. That is, you can do it if you collect it daily, you can summarize it monthly instead of daily, or combining categories to create a broader group. So data aggregation is very important. Another thing we do in data organization is data labeling. It is crucial to label the variables and provide clear descriptions to ensure that the analysis is interpretable. Labels should be concise, informative, and consistent across all variables. So also when you're doing data analysis, we do that documentation. Maintaining proper documentation of data source, data collection method, variable definition, and any other transparency is vital for transparency, reproducibility, and future reference. And finally, data storage. When we are organizing data, we are simply just putting this data in a way that it can be stored easily. The organized data should be stored securely and backed up to prevent loss or corruption. And the appropriate filing we use in computers is CSV, and Excel. These are used to store our data, so that when it comes to manipulating it or when it comes to analyzing it, it becomes so easy for us. Another way, now, those are ways in which we organize data, but there are good reasons why this data should be organized. There are good reasons why this data should be organized. What are some of the reasons why we organize data? One is for accuracy and reliability. Organizing data ensures its accuracy and reliability. And by cleaning and structuring the data properly, potential errors, outliers, or inconsistencies can be identified and be addressed. This improves the quality of the data and enhances the credibility of the statistical analysis and the finding. The second reason why we should organize data is for efficiency analysis. Efficient analysis. Proper organization of data simplifies the analysis process. Well-organized data is easier to navigate, understand, and manipulate. It allows researchers and analysts to efficiently apply statistical techniques, perform calculations, extract meaningful insights from the data. This saves time and affords data exploration and analysis. Another reason why we should organize data is for the data interpretation. Organized data facilitate interpretation by structuring data in a logical manner with clear variable labels and descriptions. It becomes easier to understand the meaning and the context of each variable. This enables researchers and stakeholders to interpret results accurately and draw appropriate conclusions. And finally, why do we organize data? The importance of organizing data is for comparing and standardization, comparability and standardization. Organized data promotes comparability and standardization across different structures or datasets. Consistent data organization practices such as using standardized variables, names, formats, and units allow for easier integration and comparison of data from various sources. This enables researchers to conduct meta-analysis, replicate studies, combine data set for more and comprehensive analysis. Having said this, the others, for example, data management and data visualization. For data visualization, well-organized data lends itself to effective data visualization by structuring data in a way that aligns with the visualization requirements. It becomes easier to create informative charts, graphs, and dashboards. Data visualization enhances data exploration, communication, and understanding, enabling stakeholders to grasp the complex patterns and trends more easily. Now, we are now going to look at how we can organize data. The following are scores collected by a researcher from a certain school. And when you look at them, they need to be organized. They are haphazard because when we are told to make meaning out of this data, it might be difficult. So we organize this data by constructing a tally table. We organize this data by constructing a tally table. And from the tally table, we can easily see the trends of the data, and we can easily see which number or which score has a higher frequency, just at a look from a snapshot, because the data is organized. The way it is, it's not organized, but we organize it. And we are now going to organize this data by looking at what is the highest value from this data, what is the lowest value from this data, and list this data either in ascending order, like we have done here. We've seen that the highest value is 95 and the lowest value is 84. So we have listed this data in ascending order, but we want now to tally it so that we see which value is appearing more frequently, which value is less represented. And by doing this, we will be organizing this data, and we can easily now start manipulating it for our statistical analysis. How do we proceed when we are tallying? We look at the values we have been given here, and we take a pen. I'm taking a red one. Now, when you have these values, the first value on our list is 86. So you cross out this value and you come to our data and you look for where 86 is and you tally it with a stroke. Then you go back. The second value is 95. You cross it out. Then you go back to your tally sheet and you look for where 95 is and you tally it with one stroke like that. Then you come back to our data. 92 is the next number. Then in our list, we have 92 there. We stroke it like that. Then we move on. 89 is our next number. Then we go on. 89 is here. We stroke it like that. We move on to the next number. We cross it out with 92. We come back and we are able to tally it like that. We have the next number is 92. We come back to our tally list. The number is there. We tally it like that. The next number in our list is 91. We cross it out. And when we come here, 91, we're able to tally it like that. We tally to a landing stroke. The next number in our list is 90. We come back to our tally. We look for where 90 is, and we tally it like that. We go back 88, and we come back to our list. 88 is there. We tally it like that. We go on again. It's 93. We cross it, and then we come back, and we are able to tally it. We move on again. Our next number is 92. We cross it, and then we come back and we tally it. We move on. The next number is 85. We cross it, and we come back, and we are able to tally it like that. We go back again. Our next number is 95. We cross it. And when we come back, 95 is there. We turn it. We move again. The next number is 84. We move back to our table and we identify 84 there. We tally it. We able to move back again and we have 88. So our next number, 88, is there. We tally it. So we move back to a number 93, we cross it, and we come back, we look for 93, and we are able to tally it like that. We go back to our numbers, the next number is 92, we cross it, and when we come back, 92, there are 4. So the 51, we cross it across. We cross it across. We don't tally it, we cross it across. If there are 4, so that we have a band of 5, 5, 5. So when we get to the 51, we don't tally it the way we are tallying the rest, but we cross it across. Now, when you have done this, you will get a table that looks like this one here. I organized it early for us so that we don't waste a lot of time tallying up to the end. And we realize that 84 is appearing 3 times. 85 is appearing only 1 time. 86 is appearing 7 times. 87 is appearing 3 times. 88 is appearing 9 times. 89 is appearing 8 times. 90 is appearing 9 times. 91 is appearing 12 times. 92 is appearing 18 times. We have 93 is appearing 13 times. 94 is appearing 10 times, and 95 is appearing 7 times. So this is what we call the frequencies. This is what we call the frequency. The number of time an item is appearing in a given data. So having done this, we now can represent this information on a table. Having collected data, one obvious method of displaying the data is in a table form. Like this table now can be able to make meaning. When somebody looks at this table, is able to see the trends in this table, and now can use this data to manipulate and also do the analysis and come out with his way of handling this data. So having the data itself, sometimes these values are too big. Like these values here, we have seen them. We might have so many values, and then one of the disadvantage of this big data is that it might become so hard for somebody to express this data in a good way. But there is what we call grouping of the data. We can group this data and have them condensed so that it can also be presented on a limited space. Because having a table, if you had so much data, it will not be easy for us to condense it. But sometimes we group data, and when we group it, it becomes easy for us to present it in a good way. And how do we proceed when you are grouping such a data? There is a process, there is a way in which we use to group this data. We first of all determine the interval for tallying the data, and these you follow the following steps. The first step is determine the range of the data. Range simply means the highest value and the lowest value, the difference from the highest value and the lowest value. So from our data, the highest value was 95 and the lowest value was 84. So the range will be 95 minus 84. So when you subtract this, you'll get that our difference or our range will be 5. So the second step is to decide on the number of intervals or categories you want to create. This depends on the size of your data set and the level of detail you want in the frequency table. For example, let us choose an interval of 5, meaning that when we have a group of 5 in each data or in each interval, we have 5 items being represented in that group that we are going to group. Then the third step is to calculate the interval width. Divide the range of the data by the number of the intervals. For example, here, in this case, our range was 11, because when you take 95 minus 11, you get 11. And then because you want your intervals to be 5, then you divide by 5, and this one will give us approximately 2.2. Now round this value up to the nearest whole number to determine the interval width. Let us now round it to the whole number. Sometimes people say 2, but I want us to round it to 3. I want us to round it to 3. Then, step 4, determine the starting point for the intervals. For example, in our data, the first number was 84, but we must choose a value that is slightly lower than the minimum value to ensure that the data set is captured. In this case, we choose 82 as the starting point. So if we choose 82 as the starting point, then step 5, we create the intervals by adding the interval width to the starting point successfully. For example, the interval will be as follows. 82 to 84. Remember, the interval width is 5 members. So we have 82, 83, 84. There are 3 in that width. There are 3 in that width because we calculated the width and we saw we are going to have 3 in each. We are going to have 3 numbers in each. So we have in this one 82, 83, 84. Then the next group will have 85, 86, 87. There are 3. Then the next week will have 88, 89, and 90. Then the next one will have 91, 92, and 93. And then finally we'll have 94, 95, and 96. Note that this interval extends beyond the maximum value because the maximum value in our case was 95. So this extends beyond the maximum value, but it ensures that all the data is captured. You can then use these intervals to create the tally or frequency table as mentioned in our previous working. We were working and then we were able to create tallies. So in this case, you are able to have this and you are able to have your tallies. And these tallies now, you have, you look for these numbers so that we have frequency here or how many times is that number able to appear. So we have, we have the first tally for 82 to 84, 85 to 87, 88 to 90, 90 to 93, then 94. I will leave this one for you to do it so that you can come up with tallies and see how many frequencies are going to be produced in this group data. Let me go over again to see that we are able to grasp what we are talking of in this place. To determine the intervals for tallying the data, you can follow the following steps. 1, determine the range of the data. Find the maximum and minimum. And in our case, our minimum was 84 and our maximum was 95. So when you subtract, the range is actually the difference between the highest value and the lowest value in your data set. And this one will give us 11. Second step, decide on the number of intervals or categories you want to get. In this case, we're going to decide that we want 5 categories. We want 5 categories in our data. Now step number 3, now calculate the interval width by dividing the range of the data by you have, which is 11, by the intervals you want to have. In this case, it is 11, which is the range, all over 5, which is the intervals we have chosen. It will give us approximately 2.2. But to a data set of 2, it's two members only or two items only is too big. So we round it off to the nearest number that we are comfortably handling. And this number is 3. This number we are comfortably handling is 3. Then we determine the starting point. So in this case, we choose 82 such that it is going to capture all the data sets that we have. Now we create our data sets by adding on numbers. So we have 82, 83, 84. That's the first category. So the second category will be 85, 86, 87. And you move on like that up to the last one. And I've said the last one is extends beyond the maximum value because it ensured the data, that all the data is captured. Thank you very much. We can now move on to another part of our data. This part of data is representing or presenting data graphically. This data, when presented graphically, will make statisticians or people or stakeholders who are looking at your data to have meaning. Because when you present data graphically, we are able to see clearly the trends and the patterns in the data. And many types of graphs or charts are used in statistics, depending on the nature of the data and the purpose of which the graph is intended. Among these, we have the bar charts, we have the pie charts, and we have the line graphs. Among these, when it comes to presenting the data graphically, among these graphs we use, we have the bar charts, and the line graphs. So I want us now to start off by seeing how we can be able to present manually our work on a bar graph. But later we will see how we can use computer softwares that can assist us come up with these graphs. The first one I'm going to consider is the bar graph. Bar graphs are the most common types of used in practice. A bar is a thick line whose width is shown merely for attention. So you can have a bar with a light line or width. Others you can have them with a very wide width. This is just for attention. The bar graph makes comparison by means of parallel bars of equal width placed either horizontally or vertically. The bars are preferred, the vertical bars are preferred because they give a better look and facilitate comparison. So we have two of them. The first one here is on our screen. This one I am calling it a vertical bar. A vertical bar. And you see, those bars are not touching each other. These bars are not touching each other. They are apart. And also we can have horizontal bars. From here on the screen, on my right hand, I'm having the horizontal, and on my left hand side, I'm having the vertical bars. And I've said that vertical bars are preferred because they give a better look and facilitate a better comparison. The gaps between one bar and another should be uniform throughout. These gaps here, you see this gap from bar 1 to bar 2. They are uniform. And when you go for bar 2 and 3, these gaps are uniform. These gaps are uniform. These gaps are uniform. They are equal in length or equal in width. Now, in bar graphs, what matters is the length. For example, from the horizontal scale is what matters, but the width of the bar does not matter. So when you're having your bars, make sure that when it comes to the width is very important. The width is not very important, but the length is very important. We want to represent this data. We have here a number of tourists visiting a given town in a year. And these numbers are given for different years. We have so we want, sorry, I dropped my, let me bring back my screen. We want to represent this data given here on a bar graph. The table shows the number of tourists visiting Disneyland. And we want to represent this data here. And in organizing data, you can see one thing here is that this data is represented as 15.1. But when you come to the narration here, we are being told these three zeros. These three zeros are actually telling us that this data being presented here is in thousands. So it means that what we have here is 15,100. This one is 20,500. So it's very important to know that we can represent this data in a way that we don't have to take a lot of space. Now, when you are drawing a bar graph, we have here the years, they are categorical. And one thing I should mention is that when you are presenting the data on a bar graph, we should present a categorical data, not continuous data. We don't represent continuous data on a bar graph. We only present categorical data. So when it comes to this categorical data, we have categorized these tourists in 1998, 1999, 2000, 2001, 2002. We are categorizing in years. We are not having continuous data here. Now, we have to choose a scale. We have the vertical scale and we have the horizontal scale. We have the vertical scale and we have the horizontal scale. Now, we come and have a uniform scale on the vertical scale, a uniform scale on the vertical scale, uniform scale on the vertical scale, uniform scale on the vertical scale. In fact, otherwise, this one should be divided uniformly. And we look at our data here. We see that the highest is 54.6 and the lowest is 15.1. So when you look at the highest being 15.1 and the lowest, so we should have our scale being able to accommodate all these values. So we would start with 0. Then this one should not be at that point. This one should be here because we're supposed to have a uniform scale. This one should be 10, 20, 30, 40, 50, then I'll have 60 there. Then I have 60 there. Now you see my scale is uniform. Then I'll come and look at the bar, the first year. The first year is 15.1. So I'll come and locate 15.1. 15.1 should be somewhere there, yeah? And I draw my bar in that manner. This is 1998. Then the second one will be 20.5. 20.5, I think there. And this bars should not be able to touch each other. So this is 19. 99. Then it's 31.8. So 31.8 somewhere there. So this is 2000. And make sure that you are able to label the axis. So this one is the year. And this one is the number of tourists in thousands. Number of tourists in thousands. So at the end of the day, you'll have bus that looks like the ones I have here. At the end of the day, you'll have the bus that looks like one here. And I've said the scale should be uniform. The scale should be uniform. And the bars should not be able to touch each other because this is categorical data. It's not the continuous data. The other type of bar is what we call multiple bars. Now, multiple bars, these are type of budgets that is used when comparisons are made between more than one characteristics. Bars representing different characteristics are placed side by side. So we have two bars representing a given characteristics. For example, here we have characteristic 1, we have characteristic 2, but there are two bars representing that characteristics. We have characteristic 3, we have category 4, and we have category 5. And on this side, we have our scale being equal. On this side, we have our scale being equal intervals. So how do we proceed? We proceed the same way, the way we did it on the other from the previous example, but this time we should draw the two bars of the data or 3 bars for the data that is given. For example, there is a table here showing television licenses, those people who are watching, who have paid for the television, and we have those who have paid, who don't like watching television, they like watching for the cinema hall, their favorite movies at the cinema hall. So in the year 1999, there are numbers, but also I'm representing this data in thousands. I am not writing thousands in the main narration, but I have summarized, I was showing 3 zeros there, showing that this data is in thousands. This part of the data is only informing you that this data is in thousands. This data is in thousands. So in the year 1999, I have 14,000 having licenses for the television, and those who are going in for weekly admissions in the cinemas were 23,000. And we proceed up to 2000, 2001, 2002, 2003, and their numbers have been given here. So we proceed now to have this data being presented on a multiple bar graph. Also, we divide our scale uniformly. We divide our scale uniformly. We divide our scale uniformly. Probably using our ruler. We divide our scale uniformly. Then we look at our both the scales here. The highest is 26 and the lowest is 11. The highest 26 and the lowest is 11. So we go here and have 0 as our starting point. So we have 5, we have 10, we have 15, we have 20, we have 25, and 30. You can proceed, but 30 should be our last number. So we look at 1999. What were we having? We were having 14 licenses for TVs. So we have 14 somewhere there, closer to 15. We draw the first bar there. But now we want to represent this one by a different color. We take another different color to represent 23 as weekly admissions in cinemas. So it will be 23. 23 is somewhere there. Sorry, this one not coming well. So 23 is there. I'm using a different color to do the representation of this. So this one is being categorical data. This is which year? This is 1999. This is 1999. Then we move on again. Take my pen again, a red one. And we are going to go to the next year, which is 2000. We had 19. So 19 is somewhere there. 19 is somewhere there here. So I have the bar there. I have the bar here. And I look at 20.5. 20.5. I take again my pen and I'll draw 20.5. 20.5 somewhere there. Not very long. 20.5. That is it. So you move on up to the end. But when you finish, you are supposed to label your axis. This is the year. And this is the number of attendance in thousands or licenses in thousands. But one important thing, you must be able to come up with a legend to tell us what each of the bars represents. So, for example, this one will be the red one. The red one, you'll draw the legend here and tell us the red one, these are a TV. And also you have the green one here. You tell us that the green one, which have been struck, it's for the cinema. It's for the cinema. So you'll get something like this. You'll get something like this. Having your multiple paragraphs presented in this way. And it's wonderful to have it in this way. You have the year down there, and you have the number of thousands, and you have the year, and you have your legend, and you see the legend is up here, showing that this color represents this and that color. This is a multiple bar graph. Then we have the third type of the bars. We call it composite budgets. And this type of budgets that is used when we want to compare the same characteristics from different sources. In this case, a bar chart for the total is drawn and then broken down into components. Here I have some data. The data I have here is total earnings in US dollars, foreign exchange for exported agricultural commodities by a certain country. And these shows the export for coffee, tea, sisal, and pyrethrum. The total for year 2000 and 2000 is 167. The total for year 2001 is 82. The total for year 2002 is 207. The total for 2003 is 205. And finally, the total for 2004 is 236. So in order for us to draw this, we follow the same procedure. The same procedure, we come up with our totals, like I've come with the totals earnings. And with these total earnings, we are able now to represent them. Like for the year 2000, the total earnings were 167. So 167 is, but now we do the division in different, we put the division in different compartments. For example, we see pyrethrum, we see sisal, tea, and coffee. We see all these being represented, like this one is for coffee. And for coffee, from our data, is 76. is 76, and 76 you see, right? It's somewhere there. And if the one that follows, you add on from 76, you add on what you have for T. 76 plus 59, you'll get a value closer to this one here. And then you divide this component so that you have your data in this manner. Finally, apart from bars, we have line graphs. A line graph is used to emphasize the changes in some characteristics occurring during an interval of time. So lines are plotted. Lines are plotted. And how do we proceed in having lines plotted? I have these data here, data showing the population of our country from 1880 to 2000. And it's a period, it's an interval of 10 years. An interval of 10 years. An interval of 10 years. We're showing this population in this country for an interval of 10 years. And we have this interval. So we can draw these intervals to show how this population is being affected. And this is how we proceed. We have our scale here. So we have a uniform scale on this side. A uniform scale on this side. We have a uniform scale on this side. So we have, let's put it there, again there, third there, fourth there, there, we go, uniform scale. Uniform scale. Then on this uniform scale, we are supposed to look from our data. What are we having? So we are having the highest being 151 and the lowest at 4. So we're going to have 0 as our starting point. Then we have, let's use 10, 10, 10, 10. So we have 10, 20, 30, 40, 50, 60, 70, 80. Or if these scales go to somehow leave other values out, we can do away with it so that we can have a scale that is good to if this scale go to have values and some of the values are going to be left out, we can have another scale that is proper using 20, an interval of 20. So we can use an interval of 20. Can use an interval of 20. You see. So we have that one there. The scale should be uniform. The scale should be uniform. The scale should be uniform. And let us use the interval of 20. So we have 0, 20, 40, 60, 80, 100, 120, 140, 160, then 180. 180. So that you have now the years also having with intervals, same intervals, because this one is a line graph, you have the years with equal intervals. Years with equal intervals, or the attributes on this should be on equal intervals. So we have 1880, 1890, 1900, 1910, 1920, 1930, and you go on like that. So you will come and identify this, but 1888 was 34. So 1888 was 34, somewhere there. So you plot that value. In 1890, it was 42. So 1890, it was 42. You come and plot that value there. 1900 was 56. So you go and look for 56 somewhere there. And you, after plotting all the values, you join them with that straight line, and you'll get something like what I'm getting here. You'll get something like what I'm getting here. So this is a line graph. This line graph is able to show us the trends in the data, is able to show us the trends of what is happening in the data that has been collected. Thank you very much. I will be presenting now in the next part how you use computer softwares to come up with computer softwares like Excel to come up with these graphs so that you can be able to present your data.